Okay, so I've got 5 different equations shown here, and we're going to walk through each one and decide whether the entropy change for this process is going to be positive, whether the products are more disordered, or whether the delta S is negative, where the products are less disordered or more ordered than the reactants are. So I'm going to read through each equation in case you can't see it very well on the screen. The first one is N2 as a gas plus 3 H2s as a gas makes 2 NH3s as a gas. Second one, CaO as a solid plus CO2 as a gas makes CaCO3 as a solid. Third one, 2Na as a solid plus 2 H2Os as a liquid makes 2 NaOHs aqueous plus H2 as a gas. Fourth one, C3H8 as a gas plus 5 O2s as a gas plus 3 CO2s as a gas. Makes 3 CO2s as a gas plus 4 H2Os as a gas. And our last one, 2 SO2s as a gas plus O2 as a gas makes 2 SO3s as a gas. Now, if you need to, pause there so you get everything written down so you're not writing it out as we're going through this. It's important to keep the states with everything because the states have an effect on entropy. So if you're writing these out, keep the states with these. Okay, pause there if you need to. All right, so we're going to go through each one and decide whether there's an increase, positive entropy, or a decrease, negative entropy associated with each reaction. So we're looking at this qualitatively. We're not calculating anything. So we need to keep track of what's happening with the moles of material, what's happening with the chemical states of material, what's happening. We can't tell the temperature very well, and we can't tell changes in volume very well, but we can get an idea of whether delta S is going to be positive or negative for each one. Okay? Maybe we'll go through the first couple, hopefully it'll make more sense. So this first reaction, 1 mole of N2 and 3 moles of H2 make 2 moles of NH3. This kind of reaction is called a synthesis reaction or a combination reaction because we take elements and we make compounds. Individual elements have more freedom than the compound does. We took smaller molecules and made bigger ones. Big molecules have less disorder, which means a decrease in entropy. NH3 is more ordered than H2s and N2s by themselves. Second one, calcium oxide as a solid, absorbing a mole of gas, producing calcium carbonate. Okay, notice how I said that, absorbs a mole of gas. So we took a mole of gas and converted it into a solid. That's a big decrease in entropy. CO2 gas has a lot of freedom of movement. That carbon dioxide is now part of calcium carbonate as a solid. Very little freedom of movement. That's a big drop in entropy. Anytime you have a molecule that has gases becoming solids or liquids, that's a decrease in entropy, a big decrease. Okay, our next one. Sodium as a solid, that's elemental sodium and liquid water, making aqueous NaOH and H2, a mole of gas. That one's the important one. Anytime you produce a gas, that gas is going to bubble out of solution and disappears. That creates more randomness. The H2 as a gas dissipates out of the solution and becomes more disordered. Anytime you produce a gas, that reaction almost has to be positive in its entropy change. Okay, the next one. We got C3H8 plus O2, 5 of those, making 3 CO2s and 4 H2Os. Everything is gas phase, so we don't have some of the other things, like in the second and third one, that doesn't come into play. So it's not an issue of producing or consuming a gas because everything's in the gas phase. But we start looking at what there is. We have a molecule with 11 atoms over here, and nothing on the right-hand side has more than 3 atoms. Okay, that's your clue that there's an increase in entropy. Big molecules becoming smaller ones. We also have 1 plus 5 is 6 moles of reactants and 7 moles of products. There's more moles of gas on the product side than the reactant side. That means typically positive change in entropy. Last one, 2 SO2s as a gas plus O2 as a gas makes 2 SO3s. Now we're going the other direction. Everything is still in the gas phase, so it's not about a change in how many gas state products or reactants there are, but there are 3 moles of gas on the left and only 2 moles of gas on the right. So overall, the reactant molecules got more ordered. So this would be a negative change in entropy. There's more order over here than there is over there. So final minus initial is going to end up with a negative entropy value. Spontaneous processes, in terms of entropy, are the ones that are positive. So just in terms of entropy, the third and fourth one in our group, those are the ones that are spontaneous in terms of entropy. So where we're headed with this, our next video is going to talk about how to calculate delta S for a reaction, and then we'll get into deciding overall, once I know delta H and delta S, is it spontaneous or not? Okay, stay tuned.